welcome to the next video. From today we will start the sorting part of the array. And first sorting part which we will be covering is selection sort. So for those who don't know what is sorting, let us go to whiteboard. Let us go to whiteboard and explore what is sorting. Okay, so what is sorting? Sorting is, this is an array, suppose 2, 54, 6, 12, 56, 7, 78 and 9. Okay, so what is sorting? Sorting will sort this array into ascending or descending order as per our requirements. So this is what is sorting is. So I should write here, sorting is arranging the array into ascending or descending order. Okay, so what this is the basic definition of sorting. So there are many types of sorting types. First is selection sort, which we will be covering in this video, and second is our bubble sort. Next is our insertion sort. Next we will merge sort also, and merge sort is recursive, or we can say divide and conquer. Divide and conquer. We also have quick sort. This also uses divide and conquer strategy. Don't be overwhelmed with these terms divide and conquer. If you don't know, it's absolutely okay as you are a beginner. So we are on the first stage also only, that is selection sort. So don't worry. So this is what our sorting we will be covering. Okay. So now let's begin with selection sort. Okay. So what is it? In this, we find the minimum element from an array, then place it in the beginning of array by swapping and repeating by iterating over the array. We will repeat these first two steps till the array it is iterated. Okay, so iteration is, what is iteration? You might be asking. Iteration is nothing but going through whole array. Means if I go from 2, 4, 6, 12, 56, this is iterating. I am moving over, traversing. I am going through it. Okay, so this is what iterating means. Okay, so now let's take this example over here only. Then we will visualize it using some tools. For first, I should tell you what is it. Okay, so now let me take a colored pen. Okay, so what we will do, we will start from here. Okay, we will find the minimum of these array. We will take this at the starting point, and from after that we will find the minimum of whole array. Okay, then we will swap it with this if it is smaller than that. Okay, if it is not, then we will go to other. As you can see, here is nothing smaller, so we don't iterate till here. Okay, this is done, and now we will go from 6 and find the minimum of these from these. We can find that minimum is 6 and it is lesser than 54, then we will swap it. We will make 6 here and 54 here. Okay, we will make here 6 and here we will make 54. Okay, so now again we will iterate from here this pointer to this pointer and we will find the minimum. Minimum we get here 7, so we will swap 7 with this 54. And we will continue this, then we will get 7 and then we will get here 54. Okay, now we got 54 here. Now we will take again from here to here, again from 56 to 9, and we will find that 9 is the minimum, so we will swap with 12 and 9. We will get 9 here and we will get 12 here. We will again move from this next pointer till the end of the array, and we will find that we get 12 here. So we will swap 56 with 12. We find here 12. Okay. And again we will take from 78 to 56. And we will find nothing is lower than that. And again we will go till the end, and we will find that 56 is lesser than 78. So we will remove this and make 56 instead of 78. Okay, so this is what we are doing. I know this is very much chaos I have created, but the basic funda I thought you have got it. Okay, so this was all about selection sort. And what is it basically doing? If I will tell you what is it basically doing, we will take a pointer. One will be pointing here and other will be pointing from the rest of the array. We will find the minimum from the rest of the array and swap this pointer. Then we will increment this pointer. Then we will swap till the rest of the array and then find the minimum, swap with this part. So this is what we are doing. Okay. Now let's visualize. So we have done what is this. Now visual representation. Okay. So this is a tool Visualgo. Okay, and I will provide the link below. So let's see what is it doing. Okay, first it will mark 3 and then find the minimum from all of the array. It will traverse through each of the things and find the minimum one. So let's wait for it to finish and see what will it come out. It will find 2, right? It is lesser than 3, and now it will swap. See, right? Then we will increment the pointer to 44, then find from the minimum out of it. 5 is lesser than, and we found 3. Then now minimum becomes 3, not 5. Now nothing is lesser than 3, so we will only take 3 as a minimum and swap with 44. Okay. Now we will increment the pointer to 38, sorry, then find from 5 to 48, which is the minimum. We have marked 5 minimum here till now, but as soon as it will traverse the whole array, it will find 4 as the minimum part. Okay, so it will change. See, the color will change. Yeah. Then it has find the minimum. It will again swap with 38. Okay. So now let me increase the speed. So you have got it. 4s. Again it will traverse from 47 sorry to 48, and it will find here 19 as the minimum one. Okay. So it has found minimum 9. Then it will traverse it and it will go on swapping and swapping, finding the minimum from the remaining array, and it will increment the pointer till we get to the last point of the array. Okay, so I'm playing this visual till it is finished so that you are able to understand what is actually going on, and I hope you are getting it. And if you think if you have any doubt or query, please comment down below. Okay, so it has been finished. Now let's move. What's the next slide saying? Okay, let's code. Now let's go to our Eclipse. I have initialized an array 26, 34, 1, 3, 89 and 5. Okay, before anything I explain about selection sort, I will tell you how to find the minimum element from an array. Okay, how we find the minimum element. Let us initialize a variable 20, sorry, minimum, and we mark it, we define it equal to first element of the array. And now we will traverse from second index till the a dot length and increment it fully. And we will compare if minimum is greater than ai. If it is, then we will change it to minimum. Otherwise, nothing will happen. Okay. So I hope you got it, what it is saying. And now see RC result is correct or not. Yeah, minimum is 1. So if you are not able to understand what is going on, let me tell you the algorithm behind it. Don't feel overwhelmed at any stage of coding. It's very natural to feel it, but don't feel it. Okay. Minimum element from L. Okay. So I have taken. Okay. Let me take other. Let me take this one. Okay. This is the array I have taken. Now what I am doing. Now what I am doing is actually I am taking this as my minimum element. Okay. This is as minimum element. Okay. And now I will traverse it. I see that 34 is greater than 26. Sorry. My base condition is that I will be doing is minimum is greater than AI. Okay. So I will check here 34 is lesser than minimum. No. So we'll move pointer to next. 1 is lesser than? Yeah. So we will remove minimum from here and write it here. Okay. Now we see that 1 is lesser than 3. Yeah. But minimum will not, this condition is not satisfied. So we will not change it. 89 is lesser? No. 5 is lesser? No. So this is the final answer of our minimum. We store it in a minimum array. Okay. So this is how we find the minimum element. So you have got the basic about finding minimum. So now let's start with our selection sort. What we will be doing in selection sort. Let it eliminate this in the Okay, so what we will be doing in selection sort, we are traversing a pointer from starting of the array till the end. And how we are traversing that the first element what we choose the pointer when the pointer is here, suppose at the first. So it will compare and find the minimum from the rest remaining of the array. And now we will increment it simultaneously. And when this is incremented, we will find minimum from next part of the array. Then when this is here, we will find from the this remaining part. When the pointer is here, we will find the minimum from the next. So we are traversing array, right? Our basic goal is we are traversing the array from here till the end of the point. So we write it in our program that int I equals to 0 to I is lesser than a dot length and okay. And now what we are doing over here, we are traversing from the next index of the pointer we have taken. Okay, so if I do like this, we are traversing from the next pointer till j is lesser than a dot length plus jj. Okay, and what we are doing, we are finding the minimum. So what we are doing, we are comparing with the pointer one element. Okay, let me take a condition where we are at the middle part. Okay, then you will understand. Like suppose our pointer is here. Like suppose our pointer is here. So what we are doing, we are finding minimum from this part by comparing this one pointer. So in this program where we have found the minimum, what will the minimum value? Minimum value will be a of I because we are comparing from where the pointer is kept and from the next till the end of the array. from next till the end of the array. And what we are doing, we are comparing. So I will copy the same code that you think that I told you. So this is what the selection sort is all about. Okay, so I have found the minimum. Now I have found the minimum. Let's suppose, let me take some number different here. Let it be 4. Okay, I have found the minimum number from here. It is 3. Okay, now I will swap this minimum with the pointer part if it is lesser than. How we will do here? When we have found the minimum, what we will do? We will check if minimum is lesser than AI. Okay, if minimum is lesser than AI, then we will swap it. Temp AI is equals to temp, and uh, okay, one thing I forgot to take is index of that minimum value. Let index be I. Okay, I only let the index be. And if we found it, we'll make index equal to J. Okay, and J equal to N equal to temp. So here we are swapped after checking. Okay, let me tell at which stage we are. When we have found the minimum, we have swapped it. Okay, this was what we have done till now. Okay, so one thing I would like to change here. It is not I J because we have directly pasted it. We were comparing with this index. We are comparing for the rest of the array. Okay, from 3 to 5. So here we have to take it from J. Okay, so this index I have taken, I have swapped. Okay, now this is our selection sort we have completed, and for int I in A. So now let's print our sorted array. As you can see here, let me take you the question. We have unsorted and now we have sorted it using selection sort. So you can take this screenshot of the code, and I will write the comments, and you can see it from the link in the description. I will also give the link to PPT and the things that I have used in the lectures. Okay. So now we have done the coding part. Now let's discuss about time complexity analysis. As you can see, we have what we have done. As you can see here, this is for loop. Let me change the color. This is for loop for n, and this is again here for loop from I plus 1 to n. Okay, so when we round off, we almost get it equal to n. Okay, because this is big O of n, so there are no assumption etc. here. We take it directly big O of n only, and we can see the time complexity of this will be n into n, because there is a outer loop of n and there are two inner loops. Okay, so we take it big O of n square, and whether we found it sorted also, then also we will sort it again. So there is no best worst case here, so all the cases will be considered equal. So this is big O of n square. Okay, I hope you got it. And space complexity we have not taken, you can see here, any additional array or something. So here space complexity is big O of 1. Okay, this is space complexity and this is time complexity. You can see here this is n and again n loop. So here this will be n of n, and this is the highest. You can see here this is big O of n and this is big O of n. We only take the functional here and not the other printing and other statements. We always take the functional code to work in. Okay, so let me write it again so you are able to understand what it. You can see this is n. The complexity is n over here of this statement. Okay, and the complexity of this is n into n. N into n. So this is the highest complexity from n and n square, the highest complexity of n square. So we take the highest complexity to calculation, and this will be big O of n square. So this is time complexity, and there is no additional array or something, so we take our space complexity as 1 only. Okay, now let's proceed to PPT. You can see here time complexity, best, worst, and average case is same, and space complexity big O of 1. Okay, so thank you everyone for patient listening. The next video will be out soon, and I will give all the links of the description. Thank you. If you have any doubt or query, please comment down below.